In this video, we're going to have a look at how to calculate the magnitude of a 2D vector. Okay, so can I ask you please put that as a title, and can you copy down everything on this slide? Remember, when that's in the top right, copy down everything on that slide. Okay, so remember, in the context of vectors, magnitude means the size or the length. So we, in that last video, this is video 2 on vectors. In the last video, we looked at how to name vectors, how to write them as column vectors, and how to draw them. Today we're going to learn how to work out the length of them. And essentially what we do is we kind of link it into Pythagoras. Okay, Pythagoras is what we use in right angle triangles to work out the length of the hypotenuse for a smaller side. And we can apply that here to work out the length of a vector, or the magnitude of a vector. Okay, so generally, if we have a vector that starts at P and goes to Q, and it is given by these components. So these components can stand for anything. It could be 6, 2, 5, 3, negative 1, 0. Okay, so if we've got a vector and we know its components, then the magnitude of the vector, so see here, see these two bars? That's what we write at the side of the vector to denote that we're working out the magnitude. So if, for another example, if I wanted to work out the magnitude of a vector t, then I would draw those bars next to it. And when I do that, that lets the examiner know that you're working out the magnitude. Okay, so to work out the magnitude of the vector, PQ, well then you just apply Pythagoras' theorem. In Pythagoras' theorem, you would square the two sides, add them and take the square root. Well, essentially the same holds true here. To find the magnitude of a 2D vector, you square the two sides, add them, and then take the square root. This is a big concept here. This is a big idea. So can you please make sure you've got everything copied down on this slide. If you need to pause the video, please do so. Okay, we've got two examples to have a look at how we actually calculate it in practice. Okay, so this is our first word example. It says calculate the magnitude of the following vectors. This is example 1. The icon's at the top right, so can you please copy down this diagram? Okay, well let's have a look. So what have we got? We've got a vector that starts at R and it goes to S. I know that because the arrow is in this direction. That means I started my journey here and I went to here. Okay, so the first thing we want to do is we want to write down this vector in its components, in component form. Okay, so I've started at R and I've went to S. How did I get there? Well, I went 1, 2, 3 along, and I went 1, 2, 3, 4, 5, 6 up. I went 3 along and 6 up. That's step 1. We need to write it as a column vector. So all we need to do now is we need to do Pythagoras' theorem, because hopefully you can see, I'll try and do a different colour here, hopefully you can see that we've now technically formed a right angled triangle where we're wanting to work out the hypotenuse. So to work out the magnitude of this vector, RS, then we put that bar either side. Well, we would do this side squared plus this side squared, and then we would take the square root. So we're doing 3 squared plus 6 squared, and then we'll square root it. You can just go straight into this line. I appreciate that at this stage there's no need to put in the brackets, but when there's negatives I would always put it in. Always put those brackets in there. Okay, so let's see, let's keep going. So 3 squared is 9, 6 squared is 36. So that's going to be the square root of 45. Where possible, if you can simplify your answer as a third, always try and leave it as a third. Okay, always try and leave your answer as a simplified third. So think about what square number goes into 45? 9. 9 5s are 45. So we can split this up into root 9 times root 5. So the length of this vector is 3 root 5 units. Okay, so your strategy is to write it as a column vector in component form, and then we can apply this formula here. It's just Pythagoras. Okay, one more example. Calculate the magnitude of this vector. Once again, can you please copy down this diagram? So this time we've got the vector A. So we want to write it in component form. So we're going in this direction. That means that the journey started here and it finished here. So how did this journey go? Well, how did I get here? Well, I went 2 to the left. That's 2 left, and then I went 1, 2, 3, 4 down. Okay, so that's the vector in component form. The magnitude of the vector, the magnitude of A, once again we put the bars around either side, we put our line underneath A to note it as a vector. Well, the magnitude is, well, we square this side, and we add them in square root. Once again, just Pythagoras. We're going to do minus 2 squared plus minus 4 squared. Okay, so minus 2 squared is 4, negative times a negative is positive. Minus 4 squared is 16. So that's going to be the square root of 20. What square number goes into 20? It's 4. 4 times 5. That's going to become root 4 times root 5. I need to do it over here. Square root of 4 is 2. Okay, so the length of this vector is 2 root 5. Okay, so what we worked out here is how to calculate the magnitude of a vector. We essentially use Pythagoras' theorem. The first step you need to do is you need to represent it in its component form, and then you can go ahead and work out the magnitude by applying Pythagoras' theorem. Make sure you've copied down all these slides here into your jotter, and then have a go at the questions that have been assigned to you. Thank you very much.